In this video, we're going to go over how we name ionic compounds, but we're going to start with just a review of what is an ionic compound. So remember, ionic compounds are usually between metals and nonmetals. Metals are cations or positive ions. Nonmetals are negative ions or anions. The chemical formula of an ionic compound must be neutral. That is, the positive charge of the cation must equal the negative charge of the anion to make a compound that is overall neutral. And the formula unit of an ionic compound is the smallest number of atoms that will give you a neutral compound. So sodium chloride, the formula unit is 1Na and 1Cl. Now, since ionic compounds are neutral and many elements only have one type of ion, you can really predict what a formula will be for ionic compounds. So sodium chloride, I can predict what that formula is going to be. However, if you're working with transition metals, you cannot predict what the formula is just from the name, because iron could either be a 2+ cation or a 3+ cation. It really depends on the situation. So transition metals, the formulas and the names are a little bit difficult. So let's actually talk about naming ionic compounds. And we really have a lot of common names for our ionic compounds. For example, table salt and baking soda are really ionic compounds. However, if we're talking to scientists, these common names aren't great. Because imagine talking to a Chinese scientist and saying, well, we're working with baking soda. They might not know what that is, what compounds or elements make up baking soda. So we need a systematic way to name our ionic compounds. So we have systematic names. And these are great because even if you're not familiar with a specific compound, if you have the systematic name, or rather if you have the chemical formula, you can determine a systematic name from that. So let's see how we do that. And the first step is determining, do you actually have an ionic compound? That is, do you have a metal and a non-metal and an ionic bond? Once you have realized you do have that, you have to decide, okay, does my metal form only one type of ion or does it form more than one type of ion? And if it forms only one type of ion, it's usually a group 1 or a group 2 metal. If it forms more than one type of ion, it's usually a transition metal. And we can see that here on this slide. So remember, when we talked about periodic trends, we said that group 1 and group 2 metals really want to look like noble gases. And so to do that, the group 1 metals only have to lose one electron to give it an overall charge of +1. So all the group 1 metals are only form a +1 ion or cation. Same thing for the group 2 metals. To become like a noble gas, it has to lose 2 electrons, so it becomes a +2 cation. However, the transition metals don't just have one ion form. They can take on multiple ion forms, and so that is why we don't list them here. Some transition metals do only have one ion form though, like silver, zinc, aluminum, and strontium only have one ion form, and so they're listed here. But generally, if you're working with a transition metal, you cannot assume it only has one ion form. Alright, let's look at naming these binary compounds with metals that only have one type of cation. And binary compound is just a compound with two different elements. And naming these are simple. You just get the name of the cation plus the name of the anion, and you just change the ending of the anion name to have "ide" in it. For example, NaCl. The metal is sodium. The nonmetal is chlorine. You change the ending to "ide" to get sodium chloride. Same with potassium chloride and calcium oxide. And here in this table, we just have a list of the base name and then the anion name. So it's always fluoride, chloride, bromide, so on and so forth. And so let's test this out. I want you to figure out what is KF, NABR, MgS, and cesium fluoride. Take a minute, come up with answers, and come back to the video when you have those answers. Alright, so let's look at this. KF is potassium, F is fluorine, so it's potassium fluoride. MgS is not sodium, so sorry, I skipped one. NABR is sodium bromide, MgS is magnesium sulfide, and cesium fluoride is CSF. So you are expected to be able to switch between this if given a periodic table. That will be expected of you. Now, let's go into ions that form multiple types. So this title is wrong. There are multiple types of metals now. And what you do is you list the metal like you did previously, but in parentheses you list in Roman numerals the charge. So Fe2 plus would be iron 2. Fe3 plus would be iron 3. And then with the anion, you do the same thing where you have an ide. So chromium 3 bromide. So you might be asking yourself, okay, from this, how do I know I'm working with chromium 3? There's no 3 plus here. And the way we know that is from bromine. If you look at a periodic table, bromine is a group 7 element. So to become like a noble gas, it has to gain an electron. So the anion of bromine is -1. We have 3 bromines, so overall this charge is -3. We only have 1 chromium, yet we know this whole molecule has to be neutral, so this chromium must have a charge of 3 plus, so it must be chromium 3. Same thing with copper oxide. Oxygen will always have a -2 charge. Therefore, for this to be neutral, copper has to have a +2 charge, so we get copper 2 oxide. So it's the name of the metal, the charge of the cation in Roman numerals in parentheses, plus the base name of the anion. And here are some common types of cations with their charges. So question for you, what is the name of this compound? FeO. Take a second, pause the video, answer it, come back when you have it. And the answer is iron 2 oxide. Remember, for copper oxide, I said oxygen is always -2. Same thing with iron oxide. So this is -2. And then, so iron has to be +2 to make this neutral to give us iron 2 oxide, or the common name of rust. Alright, so what if we're dealing with a polyatomic ion? Remember, a polyatomic ion has multiple nonmetals that are bound together through covalent bonds. And so we have a special naming system for polyatomic ions. And most polyatomic ions you're going to run into are oxy-ions. That is, they're anions that contain oxygen. Now let's look at the naming system here. And a lot of these names are not obvious. Acetate, carbonate, hydrogen carbonate, hydroxide. So what I would recommend is actually to make flashcards that have the name on one side and the formula on the other side, because you are going to be expected to know this. You're going to be expected to know OH minus is a hydroxide. Let's look at some of the polyatomic ions made of the same type of atoms. For hypochlorite, chlorite, chlorate, perchlorate. So these follow a pattern. Hypochlorate means the smallest number of oxygens. Ite means 2 oxygens. 8 means 3 oxygens. And per-8 means 4 oxygens. And we see that in nitrite and nitrate, sulfite, sulfate. So for these polyatomic ions, the either beginning or end of the name can give you information on how many oxygens are in your polyatomic compound. So again, let's do a question. So what is BaNO32 and what is sodium hydrogen sulfite? Give you a minute to figure that out. Pause the video, come back when you have an answer. Okay, let's look at the answer. So barium, Ba, dinitrate. So first, 8. We have 3 oxygens, so it's a nitrate. And now let's look at this di part. We're going to go over this in another video, but this parenthesis is saying you have 2 of these nitrate molecules. That's what this parenthesis and this 2 are telling you. Since you have 2, you have to name it such, so it's di 2 nitrate. You have 2 nitrates. How about sodium hydrogen sulfite? So sodium, hydrogen, and sulfite. So here it's a little bit different. So sulfite is 3 oxygens, sulfate is 4 oxygen. So sulfite would be SO3. Alright, the last type of ionic compounds we're going to talk about are hydrates. That are ionic compounds that have a number of water molecules attached to them non-covalently. So you name them like other ionic compounds, but then with our water molecules you add a prefix and then hydrate. Hydrate is saying that you have water around them. And the prefix is just the number of water molecules you have in your compound. And so we have prefix, common hydrate prefixes here for hemi is half, mono, di, tri, tetra, penta, hexa, hepta, octa. So these all prefixes should be familiar from your math in your various math classes that you have taken. So let's look at this compound, BaCl2 6H2O. So you name the ion compound, barium chloride, and then you have 6 water molecules. So you have hexa and then hydrate. Simple, right? So again, let's try to test yourself. What is COSO4 7H2O? And what is iridium 3 bromide tetrahydrate? Pause the video, come back when you have an answer. Alright, let's take a look. So CO, cobalt, SO4, sulfate, 7, heptahydrate. Cobalt, sulfate, heptahydrate. Iridium, IR. Bromide, well there's 3 because iridium has this 3 plus. Bromine is always -1, so you need 3 of those. Tetra, 4, hydrate, water. Alright, that's it for this video. See you in the next.